So question 2 is asking, so given samples from a random distribution which we have not actually seen before, we want to use the samples to try to determine the expectation and the variance. So this question is asking about how we can estimate the expectation and mean from a given number of expectation and variance from a given number of samples. Part 1 is fairly straightforward. It's asking us to prove that the expectation of the estimate of the mean is going to be equal to the expectation of any one of the random variables if they're all IID from the same distribution. So we have m is equal to sigma xi, I is equal to 1 to n divided by n, right? We have n IID random variables and m is equal to the sum of all those divided by n. Therefore, expectation of m is equal to expectation of sigma. I'm going to get rid of the coefficients or the limits I is equal to 1 to n because it's obvious. And since expectation is linear, we can pull the constant out, sigma xi. Once again, since expectation is linear, we can pull the sigma out. Here I'll put the limits, I is equal to 1 to n. Now we know that the expectation of xi is going to be the same for all xi because they're all independent and identically distributed. Therefore, the expectation of all those random variables is going to be exactly the same. Therefore, we have the sum over n of the exact same quantity. Therefore, we have n divided by n of expectation of xi, which is just equal to expectation of xi. Therefore, expectation of m is equal to expectation of xi. That's it for part 1.